Hi there, this is Jacob Nash, Precalculus Lessons, and this is Unit 1, Lesson 5 on Parent Functions Review. So remember, you might remember from Algebra 2 that all of these different functions that you learned, and now let's try to remember what they were like. And some of them you also even knew in Algebra 1. So, I already put in the parent function name and equation, but now let's just look at the graph. I'll fill in the graph domain and common points. So for linear, what the graph will be like, this is when there's a line. So I'll try to do this, it's kind of small area, but the normal function would look like this. And since there's no discontinuities at all or any breaks in the line, the domain would be all real numbers. Now for the absolute value one, well, technically I could put the range on here too, but I only put on the domain. But it's good to know the range too, because for this one, I can already say that the domain's going to be all real numbers, but the range wouldn't be. But I don't really have time to put that on here right now, but just know that. That's review anyways. Absolute value function kind of looks like a V. If you think about it, that makes sense, because no matter what point you put in for the x, it's always going to end up positive, and all the positive values are up here, the y values. And so that's why there's nothing below. So once again, the domain is all real numbers. For the quadratic, hopefully you remember that. We've even gone over that in this course. That's what looks like the U, and it's like a parabola. And the same thing with that, no matter what you do, if you square a value, it would always be positive. So that's why all the y values are positive. And once again, domain is all real numbers. We'll look at common points in a second, since I'm not doing that. But then the cubic function, this one kind of, I don't really know what that looks like. Sort of like a snake shape, maybe, or something, or like a fan blade. I don't know what you would say for that. But any values that you cube can be negative. That's why it can be, y can be negative. But domain is all real numbers also. Alright, what about this one? Square root function. Now this is technically the inverse of the quadratic, and occasionally you can see it like this, but for this purpose we're only going to have the top part. And so the top part, that's what that's like, because the quadrant that the values are in is only right here. That makes sense, because values can be negative here. We can't have negative values for squares. So the domain is not all real numbers this time, because it starts at 0. Does include it, so bracket 0 to infinity. Cube root function is the inverse function. Remember, inverse is just if you change the y and x, and it's just like the opposite. So if this is the opposite of cubic function, so think about that. If we switch to y and x here, that would be x equals y cubed, and to get y by itself, you would take the cube root of y and x, and you would end up with y equals cube root of x, which is what that is. And this one looks like this, like it's just turned sideways. But the domain is still all real numbers. Reciprocal or rational function, this is the one that has some asymptotes, and when it's just the parent function, has asymptotes at horizontal and vertical asymptotes at x equals 0 and y equals 0. Why? well, remember to find any vertical asymptotes, we would see if there's any factors left in the denominator. There is x, and so set that equal to 0, x is 0. And then why there's a horizontal asymptote is because the degree of the denominator, which is 1, is greater than the numerator, which is 0, since there's no x. That means y equals 0, horizontal asymptote. Exponential function, this one, if you think of something rising exponentially, that's what it looks like. And oh, I forgot to say for the reciprocal function, we have negative infinity to 0, not including 0, and then 0 to infinity. Same thing with the range for that one. That would be the same. Alright, exponential, all real numbers. Logarithmic, sometimes it's hard for me to say that, huh? That's the inverse of exponential. And this one, that one kind of looks like, I mean, if you remember, there was even like the natural log one, but it instead looks like this. And that would be all real numbers. So, and even though it kind of looks like that it sort of looks like there's an asymptote the way I drew it, the x values for this one at least are just changing very slowly, but they will go to infinity eventually. So the range would be that. Well, that's why the domain is that, but same thing with the range. All right, common points. Common point that you should know for linear. Let me do this so it's easier to see. Okay. Common points for the linear would be 0, 0. And why we need to know this is the next lesson's on transformations. And you can use that point to change it to know where the new thing would be. And that's what we've done before in Algebra 2. Absolute value of x, we can also know that there's 0, 0 there. Well, actually, these functions, most of them do have that as a point. But you have 0, 0 here too. But it could be useful to know if we had x value of 1, that would mean 1 squared is 1. So we also would have 1, 1 for this one. So we go ahead and put that. 0, 0 also for the cubic function. Then if we did, let's just do 2. 2 cubed, 8. So 2, 8 would be also a point. Square root function, 0, 0 is a point. But let's have 4. If you had 4, then the square root of 4 is 2. So 4, 2 is a point. Cube root also has 0, 0. Let's see, 8. Cube root of 8 is 2. So see how those are inverses. These two. Rational function. Well, let's see what happens if we try to do 0. Plug in 0. 1 divided by 0. Not a thing. Why? Because we already said 0 is not a value. That's the only one that's excluded. So, no. Let's try 1. 1 divided by 1 is 1. So 1, 1 is a point. What about 2? That means 2, 1/2 is a point. Oh. Alright, for the next one. Oh, I forgot to say, this kind of looks strange because there has to be a certain base, and that's the same thing with the logarithm one. So for now, I'm just going to do this because it would depend on the base, which would be provided. So, with that, that's your parent functions review. So, hopefully we remember these, and then we can use that on the next lesson. Thanks for watching.